Ever looked at a structure and bonding question in chemistry and thought, I just can't do it? By the end of this video, you'll be able to confidently spot all 5 structure types, even the ones that trip up most students. Hi, I'm Caroline, a former chemistry teacher with over a decade in the classroom. Now a tutor, helping students actually get chemistry. I know how frustrating this topic can feel, but I'm here to make it clear, simple, and even a bit fun. We're going to break down all 5 key structure types: ionic, simple molecular, giant covalent, metallic, and monatomic. I'll show you what clues to look for, how to avoid the common mistakes, and give you practice examples so you can test your understanding along the way. Let's dive in.
So here's how to spot what structure type a substance has, starting with ionic substances. You are looking specifically for the combination of a metal and a non-metal. And if you're thinking, well, how do I know if it's a combination of a metal or a non-metal? Then a little reminder that you can check on the periodic table. So the periodic table is split into metals and non-metals. There is a dividing line that you'll need to remember, you won't be given it, that starts underneath boron and then steps down one, across one, down one, across one, like a staircase. On the left-hand side of that dividing line, those are the metals. And on the right-hand side of that dividing line, those are the non-metals. So let's look at an example. So here we have aluminium oxide. Aluminium is a metal, needing to check on the periodic table if needed. And oxygen is a non-metal. Same process if you're given the formula. And if you're thinking, well, how do I work out the formula for something that is ionic? Then that is going to be in an upcoming future video. So make sure you hit subscribe to get notified for that one. Mg, magnesium, metal. And then here you can see we have a combination of non-metals. So S is sulfur and O is oxygen. So we still have this combination of metal and non-metals, and therefore it's still ionic. Okay, second structure type. So this one I'm calling simple molecular, but sometimes you will hear it called a simple covalent. Now, simple molecular substances are a combination of non-metals. I've given you some examples here of water, H2O, hydrogen and oxygen, both non-metals. Carbon dioxide, CO2, again, carbon, oxygen, both non-metals. NH3, you might know the name of that one, so see if you can guess it before I tell you. It's called ammonia. But in ammonia, we have nitrogen and hydrogen, both non-metals, so that is simple molecular. Those first 3 examples I just gave you, those are compounds. We have 2 different elements joined together. But we also have different types of simple molecular substances as well. So the other examples I've given here, these are elements, hydrogen, H2. There we have 2 hydrogen atoms joined together, and both of those atoms are non-metals. So that still fits into this simple molecular category. Other examples there, N2 and S8, so nitrogen and sulfur. Okay, so those are simple molecular substances. Now let's look at giant covalent. Now, in order to spot a giant covalent substance, then you need to learn what I am calling the big 5. So at GCSE, there are only these 5 substances that have a giant covalent structure. We just learn them so that we can recognize them when they come up. So the first one that I'm going to talk about is carbon. Now, carbon, the formula is just C when it is giant covalent, but it actually exists in 3 different forms: diamond, graphite, and graphene. So by the formula alone, you couldn't necessarily tell it's diamond, graphite, or graphene, but you know just from the formula C, oh, that's one of the big 5, therefore it must be giant covalent. The other 2 are less well known, so silicon and also silicon dioxide. They are also giant covalent. So diamond, graphite, graphene, silicon and silicon dioxide, those are your big 5 to remember as being giant covalent. The fourth structure type, metallic. So metallic does what it says on the tin. Any metal will have a metallic structure. So again, we go back to our periodic table and look at anything on the left-hand side of that dividing line, and that would be metallic. I've given you 3 examples there. So K, Ti, and Mg. You could find those symbols on the periodic table, see where they are. We have potassium, titanium, and magnesium, all metallic substances. Now the final structure type is called monatomic. And if you're thinking, I haven't heard of that one, then it does tend to get less airtime. But monatomic is group 0 elements and only group 0 elements. Group 0 elements on the very far right-hand side of the periodic table in a long column. Some examples there are helium and neon. For more info on all of these structure types, again, subscribe because I'm going to go through them one by one and let you know in full detail about each of these. Now, some common mistakes. So where might you go wrong when you do this? First of all, I'd say it is one of the most important skills in structure and bonding, because if you read a question and you get the structure type wrong and you start talking about the wrong words like molecules, ions, etc., quite often we lose all the marks and we go no further. So that's why it's such an important skill, and watch out for these common mistakes that could just catch you out if you're not careful. So for example, we have acids and alkalis. Now acids and alkalis we would consider ionic. Some examples there might be sulfuric acid, H2SO4, hydrochloric acid, HCl, sodium hydroxide, NaOH. Now, I will caveat, and this is kind of like top level GCSE / A level a little bit, the acids and alkalis are ionic when they are molten or dissolved. So when they're a liquid or when they are dissolved in water. When they're solid, we actually consider them more simple molecular. And that's because when they are molten or dissolved, the ions that they are made of are free to move and dissociate and actually act as an acid or an alkali. Probably not something to worry yourself too much about right now, but it would feel incomplete if I didn't mention it. So acids and alkalis we would consider ionic. The second one, being careful not to be caught out by, is silicon dioxide. Now silicon dioxide can catch us out because it kind of looks like it's simple molecular. Silicon is a non-metal and oxygen is a non-metal. So it could easily fit into that category of simple moleculars are non-metals. But it's not. Because it's one of the big 5, that's one of the ones that we just need to recognize and learn as being a giant covalent substance. The next one that is, I see really commonly catches people out is something called C60. Now that's also called Buckminster fullerene, which you may or may not have heard of. It's in, for example, the AQA syllabus. Now C60 often gets mistaken for giant covalent because I think people go straight to, oh, C carbon, that must be giant covalent, one of the big 5, right? But it's not. That C60 makes a big difference. And what it means is we have 60 carbon atoms all joined together. In fact, it looks like a football structure. That's what it looks like. And because those 60 carbon atoms, which are all non-metal atoms, are joined together, it's actually a molecule. Granted, it's a bit bigger of a molecule than some of the others that you'll have met, like hydrogen H2, nitrogen N2, but it's still a molecule nonetheless. And then finally, remembering that group 0 only is monatomic. And I see this mistake creep in when people look at the formula for metals. So metals, you would just give the formula no numbers, like K. Because we have like just K written on its own, then the mistake can be, oh, well, that must be one atom on its own, but it's not. Anything that is a metal is metallic. the left-hand side of that dividing line. Anything that is in group 0 and only group 0 alone have this monatomic structure. Okay, how about we test this out now? So I have some examples for us. We're going to practice together. Okay, let's have a go. So potassium oxide is our first one. We're given the name and the formulae. Potassium, see if you can work this out quicker than I can. Potassium is a metal on the left-hand side of the periodic table. It's group 1. Oxygen is a non-metal. That makes it a combination of metal and non-metal, so ionic. Number 2, diamond, C. That one we need to learn and recognise as one of our big 5, so that is giant covalent. Number 3 is oxygen, O2. Oxygen is a non-metal. 2 non-metal oxygen atoms joined together, and that makes it simple molecular or simple covalent. Are you quicker than me yet? Next one, number 4, sodium, Na. So if you find sodium on the periodic table, it's over on the left-hand side in group 1. That makes it a metal and therefore metallic. Argon, number 5. Argon, if you again refer to your periodic table, it's in group 0. And group 0 is that special group that has its own structure type, and that is monatomic. Ammonia. So ammonia, NH3, nitrogen is a non-metal, hydrogen is a non-metal. That makes this simple molecular. Second to last, magnesium hydroxide. Now there's 2 ways of approaching this one. Magnesium, first of all, we can look up or recognise that it is a metal. And then we can ignore the brackets in the formula if that's confusing you. Just look at what elements are in there. So we also have O, oxygen, and H, hydrogen. Those are both non-metals. So metal and non-metal, that makes it ionic. The other way that we can work this out is we might also recognise, a little bit later into the GCSE course, that hydroxides are alkalis, and therefore alkalis we would consider as ionic. And then finally, chromium 3 nitrate. Again, ignore the brackets in the formulae. For now, the Cr chromium is a metal, N nitrogen non-metal, and O oxygen non-metal. Combination of metal and non-metal, so again that makes this ionic.
Thanks so much for watching. If this helped you, make sure to give it a like and subscribe for weekly GCSE and A-level chemistry tips. And if you're ready to level up, check out this next video. It's a game changer.